now that we finished with our blueprint, the schematics for our object when it gets created, we could finally go ahead and create our objects. So there's as this is defined, we could create our main inside here if you want. That could be something. I would rather we put the main inside something that's more visible, right? Talk about this as we go further in, but let's say we're going to create a new class. This is just to start our application. So it's kind of visible on the left rather than by itself. Inside person, no one will know that it's there, right? So I don't know, let's say main or start or whatever you want to call it. Doesn't really matter. Let's say start to get it a bit of difference. And inside that, we're going to say main. Now, this class person, you'll notice it's a different file. This is the definition of person. For us to be able to create it, all we need to do is specify that type that we created. So person is the type. We're going to give a variable name for us to utilize. Let's say person1. And now this is where it's a bit different than our normal primitive types. We can't just put a value. What we need to do is to create that new object inside the heap memory for us to be able to utilize it. So this new keyword will create the object and associate the space required so that we could utilize it further on. So what that means is if we look at this stack, P1 here representing my person1, just to make it a bit simpler. This new keyword is going to determine how much space required and get that space within the heap memory. So what does that mean? So if we look back to our person here, the space required for person is basically all the attributes specified. So we have some strings, which is undefined yet. We got float, which we know how much space it takes. So inside the heap memory, the compiler or the computer, whatever you want to call it, will go and look for some place where you could store a float height, a float weight, and these guys are null right now, so really it's only this much space. Right? And 4 and 4. And what will happen when string name and string hair color will get defined or created, those will take another place in the heap. But for now, all the primitives together, this is the size we need. We're going to go in details about memory in the future. So when this new keyword has been specified, it will go look for a space. It will create the object person. So this is of type person. And it will give you back the address of where that is. So this new keyword will create the object and give you back an address where we'll store it inside here. Right? We talked about addresses before. Please go refer to that video. But again, the object is not this. This is not the object. This is the address of where the object exists inside the heap memory. So when we do this new, here we got to specify what the object is. We're going to create a person. And that's it. So something that's interesting with class or objects is they could take a specific type of values. The first, it could be that object. Another one is it could take the default value of null. Right? That's the default value. It doesn't have any other types of values you could put here. You can't put 0, you can't put false, you can't put those. It's either null, which represents it's not pointing to any location in the heap, so the address is empty, non-existent, or it's new, which creates the object and gives the address. This is a bit important to understand the differentiation from new. So I'll leave this. How about we do this? I'm going to leave it first null, because remember, again, it goes top to bottom. Then we tell ourselves, well, you know what? Create me the person. And now if I do system.out and I print out, let's say person1 dot, let's say name, well, we're not going to get anything because we never specify the value, but we'll get there in a bit. But for now, let me just run it. You'll notice that, let me clear my screen. You'll notice that the name is also null because string, just like person, notice the capital letter at the beginning. It's a reference type. It's pointing somewhere in the memory which hasn't been created yet. So its default value, initial value, is null. I could also print out person. So I'm not printing out its name, I'm printing out person. Just gonna do this quickly and we're gonna come back to those little things. You'll notice it's gonna give you this weird naming style. What I like to tell my students at the beginning is to think of it this way. This is the package with the class, the type it is, right? And the at afterwards is, you could consider it as the address of where it is in the memory. Okay, consider it that. So this is the type of object and this is where it's located. Now, for now, we're gonna come back to it. If I create another person and person, I'm going to name that variable person2. We have a certain power and you're going to see the use of it as we go further, but you need to understand it now. We get a certain power is we could either make it null, which is the default. We could either create a new object with the new keyword, or we could actually make it point to the same object. So now person2 is also person1. What would that mean? Well, if we print out person2 here, and we press run, you'll notice that they're going to point to the same address as we were pointing out. Because, let me bring this down for a second, because what happened is we created another variable, let's say p2 for person2, but at line 7 over here, we made the address equal the other address. So they're both pointing to the same location in memory. Right? We talked about a bit about this inside arrays, which is the same thing. So this is important because, again, these guys over here, these variables person1 and person2, they don't hold the actual person or that object. What they hold is the address of where they exist inside the heap memory. It's the same as I have a paper, and this is my student. It says where that person lives, or what's their contact details, and so forth, so on. So if I wanted that person, that student, to do something, I will have to email that person for them to do something, right? I have control of that student, but I don't have the student. This is the same thing. I have control of my person 1 and person 2, but I don't actually have the person 1 and person 2. And this allows us to do this fun stuff where two persons are actually the same. What does that mean for us? Well, it means, well, one, you saw that they're both printing out the same location, but it also means, let me see 1 second here. I'm going to say person.name equals some value. We'll talk about this in a bit. And then if I print that person1 name, and then I go ahead and I print out person2's name, let me clear the screen. So notice here, we change only person1, the variable, its name, and we'll talk about this in the next video. But you'll notice that line 14 and line 15, they're both showcasing the same value, because when we made change to one, we made change to both. Why? Because they're pointing towards where that object lives. Another example of this would be if I have two students and they live in the same house. Well, if one of them changes the house, the other one will notice it, right? Because it's his house as well, right? If one of them burns down the house, well, it's burned down for both of them. This is what's going on, okay? And this is an important concept to know, and you're going to see later phases, we're going to make some interesting things with it. I'll see you guys in the next video.